All right, so good afternoon. Yes, I put on the recording. I'm a good girl, you know. All right, so let's see. I just want to get a little feedback from you as it relates to what you learned through the exercises today. So I'll just take one from each person, and then if there's any clarification needed, of course, I'll jump in and give the clarification. Am I clear enough though? You hearing me? If I'm not, then I'll know. Dana says yes. Courtney? Good. Let's start. Good. And Rosaline is not back, I figure, because she's at school. Okay, so let's start off. And Taylor is saying yes. So let's start with Courtney. Anything you want to highlight from today, from earlier's activity?
Well, I learned or relearned quite a few things in terms of the searching by that asterisk, using the asterisk or the wildcard. Certainly the calculated fields, how to do that. That was, those are the two things I think I really take away from today.
Excellent, excellent. Dana, you're next.
Okay, for me, well, you know, it's new.
Yeah.
So I enjoyed the experience in learning how to do the queries, creating the queries, making the calculated fields. All of those things sounded so, well, it's huge, yes, to me. But then now as going through it, I realized that there's just simple steps that you just have to follow.
Yes.
The steps, and then you're okay. So it was all a new experience, learning experience for me. So I'll certainly be using it.
Yes, please. And I'm glad that you mentioned that steps are important, because when we start doing problem solving and programming, if you don't follow steps, you are never going to solve your problems. And there are certain things that you have to just go through. You know, you can't skip over anything. So the sequential format, the sequential flow is extremely important. And it's good that you pick up that that is important from even this stage. So when we start with the problem solving, you shouldn't have that much problem. I know problem solving itself, it has its challenges, but you shouldn't have that much problem because you understand that the sequencing is extremely important. All right, next on your next.
Yes, well, for me, I have never used a count in database before.
Okay.
That part is it for me. That was interesting. I borrowed it with the sum. I didn't know it was there. That's like a gem right there.
Yeah.
Right there.
Are you saying for using it?
Yes. Right. And the wildcard, I've never used it before. I'm familiar with it. But I've never used it successfully before.
Yeah.
In database either. Yeah.
That's the where you're talking about? The where?
No, the wildcard with the S. I've used that like I'm searching. Right. When I'm doing searches on the computer, I've used that. But I've never used it in database before. So yeah. Those two things are new.
All right. Jessica, my quiet student.
I think, you hearing me?
Yes, I'm hearing you now.
Yeah, I think everything we learned today, creating a query.
Jessica, you're gone again. Yeah, hearing you now.
Okay, I think my computer is just doing whatever on its own. Yes, like I was saying, everything in that we learned today, creating queries, sorting data, entering the formulas to do the calculations. I've learned, well, I think I've learned that before, but I guess I forgot because I haven't been using Access. So I'm relearning everything right now.
Excellent. All right, so it is not a waste of time at all. That's great.
No, definitely not.
Good. Ophelia?
Right, okay. I've learned a lot. Since I've always wanted to learn it, it has become fun to me, although it's a bit challenging, but it has become fun to me. And what I like about it most is that it's real. It's not anything that I cannot use.
Yes.
It is real, and I'm actually seeing, like, doing it. I'm actually seeing everything is vivid, is life. So I enjoy that about it. All I need to do now is to practice so that I can become a pro like you.
Oh Lord. All right.
Yeah, that's all.
Compliment with a smile, miss.
I like using it.
Yeah. I asked Courtney already. Rosalie not here, so Theodore is next. Yeah. Can you hear Theodore? Hello. All right.
Hello. Okay, good, wonderful. For me, it was feedback.
That's me, sorry.
No problem. For me, it was the practice, really, really helpful. And like Ophelia said, the fact that it's real things, you don't have to put your imagination to work. It's stuff that we do all the time. We work with data. And the what do they call them? The summary tools, the grouping and the counting and the sum and the averaging. I found that especially helpful.
Excellent. All right, I feel good. At least I'm hearing that this is something that is practical, something that will not just, you get a grade and that's it. You'll use it. Rosaline, glad to have you back. We're just you're last. We want to hear anything that you learned from the previous session that spoke to you, and what the experience was like.
Yes, I have to say thank God for this course. I mean, it looks a little bit scary in the sense that, you don't know what to do, so you feel nervous and all that.
Right.
But I have to thank God for you.
Aww.
And the way that you stay there with us, you guide us, that kind of thing, it makes me comfortable. And seeing that I came in late today, I must say that I catch up. Although I'm not done with activity 1 because I had to stop to look at what's happening, but I'm done with activity 2, and I've completed the latter section of part 1. So I now have to go and do the previous section.
Yeah.
And I find I did well. I mean, the state of mind that I had today and seeing what I have accomplished, I have to, thank God for you and thank God for my classmates who have helped so far. I think this database it's exciting. It's very practical. It's very important, something that you can use. I mean, when I see we had to calculate GPA, I mean, I've heard about GPA, and to see, wow, I could just, add just a little click, calculate GPA. I'm like, wow, this is so interesting. I want to learn it.
Right.
I am desperate to learn this thing.
Aww. Excellent.
It is something that I can use. And as Ophelia said, she hoped to be like you.
Oh, Lord.
But I think I think it was, I don't remember, there was this story in the Bible. I think it was, I don't remember who it was, but maybe Talia could help me because she always quotes scriptures. Maybe she knows, or Courtney. But I think one of them said that they want to be better than their teacher.
And that's a good thing. Don't
yes, so this is my desire.
To yearn for more,
Yes.
So we can add to the wealth of knowledge out there. Yeah.
Exactly. I always tell my daughter, I don't want her to be like me. I want her to be better than me.
Better, yes.
And I'm sure that's one for us. So this is my aim and my goal and my desire to get to know this thing well.
Well, yes.
You know? And I thank God already for helping me, you know, to get to know it well. And thank you so much. Sweet attitude. I can achieve great with that attitude that you have.
Aww.
Thank you so much. And my classmates, wonderful classmates.
Yes.
You know, thank you so much.
Supportive.
Yes.
Supportive.
Yes. I agree.
Yes.
All right,
you know, just imagine I'm trying to help my students in the kitchen and I'm here, you know, and I'm relaxed.
Yes. So that's a good thing. Yeah.
Yes. Thank you.
All right. So what we're going to be looking at for the next hour and a half, we're going to be looking at normalization, because it's just a big word. But what it is a process of ensuring that you have the right tables, you have the right number of tables, and you have the right attributes or the right fields in the tables that you have. So the ones that we have done before, they're very straightforward. So you find that you won't have a lot of errors taking place. But if you're going to create a system, maybe for your school, a grading system, that's a big system. So you don't want to just get up and make tables as you feel led. Because if you do that, it means that your database wouldn't have a good structure. It wouldn't have a strong foundation. And what will happen is that the relationships between the tables and among the tables would not be firm enough. So what we do is that we go through a process called normalization, where we assess the entities that we need, we assess the attributes that we will use, and then we try to look at each table and see if it is error-free, so that we don't have any issues when we start to run our queries and when we start to run our reports and all those things. We don't have those kind of issues because we have a strong foundation. So that is what we're looking at today, the process of normalization. All right, so if you look at the notes, I'm going to share my screen with you now so that we can go through the notes together. But the notes are actually online. Let me just bring this down. Good. All right. Okay. All right, so let us start with what is normalization. So normalization is that technique of organizing data in the database. So you know what is our core function. We're looking at every table or every entity in our database, and we're going to zoom in on the attributes or the fields. Remember that we looked at fields already, those are the columns, right? So we're looking at how we organize the data in our database, what will go into this table, what will go into that table. Now, this methodology addresses the problem associated with data duplication. So you don't have one table with the same kind of data that another table has. That don't make no sense, right? So we try to get rid of data duplication, insertion, deletion, and update. So these are the things that it is going to address: duplication, insertion, deletion, and updates. So normalization is a systematic approach of decomposing tables. So you think of a table that you will need, and when you look at that particular table, you're going to see that there are opportunities for more tables from that one table. All right, so what we're doing now is trying to eliminate redundancies and undesirable characteristics. So what are anomalies? Because we need to know what those are. I'm sure you hear me use that term anomaly, but it's really just errors or problems. So it's the problems that occur when you have a poorly planned, unnormalized database. So when your database starts giving you all kind of foolishness, when it's a big one, then what is happening is that you have some problems. We call that anomalies. All right? So let us look at the three types of anomalies. We have the insertion one, the update, and delete. Now the insertion anomaly, it deals with what if we want to insert something into our database? If we add something to the database, is it going to throw off other attributes? Is it going to affect the other attributes in a negative way? So certain attributes cannot be inserted into the database without the presence of other attributes. So that's your insertion anomaly. So for example, we can't add a new course unless we have at least one student enrolled. So how is it that we're going to add a student to a course unless we actually have that course existing? So you see the dependency there, right? How are we going to add an address to an employee without having that employee there? So the insertion anomaly deals with that aspect. So this example, I think, helps to clarify what insertion anomaly is. So we can't add a new course unless we have at least one student enrolled in the course. The update anomaly now exists when one or more instances of duplicated data is updated, but not all. So what this is saying is that you may have updated the address for an employee, but when you update the address for the employee, you didn't update address again somewhere else. Let us think about it in a school environment. The office, admin might have, information on students, yeah? And they also have the address of that student and the parent and the phone number and so forth. However, the form teacher collects data also. So what is happening is that we have data on the student by the form teacher and data on the student by admin. Now, what if the student moves to another address? What is going to happen there is that maybe the form teacher will know and make the changes in her records, in her database, but the admin doesn't know. So if in the holidays something happened and the principal or someone is trying to get in touch with the child, the guidance counselor, whatever, they would have gone to the wrong address because of the update anomaly. You change it one place, but you didn't change it somewhere else. So you can see the big issue right there. Let us look at the deletion anomaly now. So this exists when certain attributes are lost because of the deletion of other attributes. So you choose that, you say, you know what, I don't want this attribute anymore. But because you say you don't want this attribute, and because of how you design your database, by deleting that one field, you would have deleted other fields. And that is what we call a deletion error or problem, deletion anomaly. Any questions so far? No? All right, so let's move on. So let us look at problems that without normalization. So without normalization, it becomes difficult to handle and update database. You don't want that. Without facing data loss. So it becomes difficult to handle and update database without facing data loss if you don't have normalization. So the insertion, updating, the deletion anomalies are very frequent if database is not normalized. So we have to ensure that we normalize our database. And the ones that I gave you before, that was very simple. The only two tables, there's nothing there to worry about. But as I said to you, if you're thinking about doing up a big system, then you shouldn't really start doing up tables until you have designed and dealt with all of them being normalized. All right, so to understand these anomalies, let us take an example of student table. Look at the student table and tell me of any possible anomalies that can exist. Whether insertion, deletion, updating.
Looking at the table, I can see that there are two fields for Adam, but different subjects. Couldn't they just put one field and have both subjects in that field?
All right. Now, what you're recommending is the first step. Actually, Dana, that's good. That's the first step in the whole idea of normalization. So yes, we don't want two representations of Adam. Agree? Because what can happen is Adam might change address, maybe move to St. Lucia, Dana, and then you only change it in the record with the ID 401. But you never change it for the record 404. And let us think about this as not just as a table with just 4 records in there. What if this table had 1 million records in there? You can see the problem there. So we really just want to represent Adam using one record. Agree? So yes, Dana, I agree with you. We should get rid of this duplication of Adam. You notice Adam has 2 ID numbers? 2. That's not good. So you can see that there's an issue there with what? Updating. Yeah? What if we add, oh, let me not preempt. What else you have to add to that? Anybody? So we saw an updating anomaly that Dana highlighted.
If you wanted to delete Adam's record altogether, it's a possibility that you could delete one and leave one as well.
Exactly. So, yes. So you're saying, what if you wanted to delete 404?
Let's say you don't want to keep any more records on Adam for whatever reasons.
Yes.
You decide to remove him from the entire database. And it's a possibility that you could remove ID 104 and ID 101 is still there.
Oh,
or
I agree. But what if we were trying to remove Adam, saying that Adam no longer does bio? Maybe he does chemistry instead. Do you see something happening there? So what if we had taken on the approach that Dana recommended? Dana was saying, let us merge all of Adam's data, and then in the subject opted, we would have bio and physics, right, Dana? All right. So what if we, you see, the thing is, Dana's suggestion would make Courtney's situation go away. Agree or disagree? Because if we have only one representation of Adam, by Dana's recommendation, then everything relating to Adam will go. But all right then, what if we wanted to know all students who does physics? All students who do physics. Then we would have a problem. Why? So Thalia agrees that we would have a problem if we wanted to know. It's supposed we wanted to do a query. And that query is to reveal the name of all students who do physics only. Yes, I'm dropping in the only because of what I just said. Anybody? You see that Dana's approach is a first step really, but it's not the end of it. Because what is going to happen here is if I wanted to perform a query on this, if Adam is going to have in the subject opted, he's going to have bio, physics. There's going to be an anomaly there because he doesn't only do physics, he does bio also. And if you wanted all the students who do physics only or all the students who do physics, you're going to have an issue. Because too many info in one field. Do you realize that when we were doing the database before, all the other activities, did you realize that we only had one data per field, per cell? We didn't mix it with more than one. Because if we mix it with more than one, we're going to have issues. All right? So let us look at the first thing as it relates to, so can you identify the anomalies? I asked that already. So let us look at some things that came out. So we have a table in front of us. Updation anomaly. To update address of a student who occurs twice or more than twice in a table, we will have to update S address column in all the rows, else data will become inconsistent. We said that about updating. Insertion anomaly. Suppose for a new admission, we have a student, we have the ID number, name, address, but if student has not opted for any subjects yet, then we have to insert a null there, leading to an insertion anomaly. What if the student has not decided on the subjects he or she is going to be doing? Don't you see that you have an issue there? Because there's no subject by the name of null. So when you put the null there, that's a problem. So what we're saying is that if you don't have all the information, you can't create the record for the student. And that's not good. The deletion anomaly now. So if the ID401 has only one subject and temporarily he drops it, that means that he's no longer going to do bio. When we delete that row, the entire student record will be deleted along with it. That's not good. What if Alex says, you know what, I'm going to drop math. Later on, I will choose another subject. What's going to happen to Alex? Everything relating to Alex gone. It's as if he never even entered the school. So that's not a good thing. Any questions? No? All right. I hope you're paying keen attention, because when it's all said and done, you're going to be asked to apply the knowledge, right? So let us look at the steps in normalization. So the process involves applying a series of tests on a relation to determine whether it satisfies or violates the requirements of a given normal form. So when a test fails, the relation is decomposed into simpler relations that individually meets the normalization test. 1 second. Give me a second, please. I want to the room. No, ask the guy around the back to open here for us. But you can't walk through. Our class is going on. Huh? So close that door. Yeah, you can't do that. Sorry about that, guys. All right. So the higher the normal form, the less vulnerable to update anomalies the relationship becomes. To update anomalies, the relations become. All right. So I'm trying to refocus. Sorry about that. All right. So we try to ensure that our normalization process. 1 second. All right. Okay, so we're going to try to ensure that we go up to the highest normalization stage to ensure that there is no issue as it relates to normalization. So the 3 normal forms are the first normal form, second normal form, very easy to remember, third normal form. And that's where we're going to stop. Yeah, because most times we're quite fine up to the third normal form. But then if we're not okay up to the third normal form, then we'd have to go to the BCNF, right? That's a Boy Scout normal form. But for our class, we're just going to go straight up to third normal form. So if you choose to teach Cape IT, you'll be good, because that's what Cape IT asks you to do. You teach right up to the third normal form. So these normal forms are based on the functional dependency among the attributes of a relation. Any questions so far? I know what you're waiting on. You're waiting on an example. But before we go further, Courtney smiling. Before we go any further, tell me what you understand so far, so I don't run leave you. Let us get the smiler first. Courtney?
Well, so basically, they're saying that, you know, normalization is basically organizing your data to reduce redundancies and to avoid anomalies. There are 3 types of anomalies: insertion, update, and deletion. And I guess insert is when you're trying to put in something and you're unable to do so. Delete
it says something, see a record.
Right.
Yeah.
A record. Yeah. Update is when you try to update something, but it may not update other things because you have multiple instances of the same records or things in different tables in the database.
Yes.
And the deletion is where you try to remove something and it might end up removing all of the related stuff, or you're just able to delete just one portion of something with leaving other things that are dependent
On it, right. Excellent. I think Courtney did an excellent job on that one, and he took over everything. So thank you, Courtney. Let us move on to the steps now. Now, what is step one? Step one is just having your data in that unnormalized form. So you select the data source that you need, wherever you're going to get your data from, look at it and convert it into an unnormalized table. So you just make a table from your source. The source could be a receipt, it could be from a mark book, it could be anything, a demographic form, you know, whatever. Just make one big, ugly, unnormalized table, right? That's step one, right? Step two now is to take that unnormalized table and put it into first normal form. Then step three is to take the first normal form and convert it into second. So you notice that we can't jump from unnormalized straight down to second. We have to go through the stages. Unnormalized to first, then to second, and then from second to third. So you have to follow those stages. All right? So let us look at the other steps now. Now, if you go up to third normal form and there is still opportunities for anomalies, then you're going to have to look at the other stages, which we're not going to be looking at today. But what are they? We have the Boy Scout normal form. Then if that's not enough, we'll have to go to the fourth normal form and then the fifth normal form. Remember that the one that you're currently at is dependent on the previous one. The most updated form, that's the one you're going to be working on. All right, so let us look at the first normal form. So we have no two rows of data that contain repeating groups of information. And that's what Dana saw first. Dana saw that we had repeated information as it related to Adam. So first normal form says, you can't have that. So no two rows of data is going to contain repeating groups of information. So for each set of columns must have a unique value. We call that our primary key, such that multiple columns cannot be used to fetch the same row. Each table should be organized into rows, we know this already, and each row should have a primary key that distinguishes it as what? Unique. We know this already. So the primary key is usually a single column, but sometimes more than one columns can be combined to create a primary key. And we call that our compound key or compose or composite key. Remember, we looked at all of that the last class. So that's what the first normal form is saying. We should not have any repeating groups of information. The fact that you have repeating groups, something is wrong. So let us look at how we will convert our unnormalized form or table into first normal form. So we're going to do what Dana recommended. So we have Adam now, just the age, and the two subjects that Adam is doing. We have Alex, age, Matt, Stuart, age, and so forth.
So it's not that we took out the last name. The assumption is that the last name.
No, the last name wasn't there. It was address that was there. Address was there. So in first normal form, any row must not have a column in which more than one value is saved. So what is happening here is that when we look at this table, we realize that we have more than one value is in a particular column. So like separated with commas, that's what we're seeing right here. Rather than that, we must separate each. So the first normal form is asking us to blast it. When it's all said and done, you're not going to see any repetition though. Right. But the first normal form is asking you to blast it. So if you have repetition here, like what Dana had recommended, we're going to take that and we're going to blast Adam. So you notice that Adam is now blasted. So we have the unnormalized table, and now we have it blasted. So we have two representations of Adam, but we're not finished as yet, you know. That's just the first normal form. Wake up, failure. And that boring? Okay. So using the first normal form, data redundancy increases because we see a lot of repetition. And that is why we can't stop at the first normal form. We can't, because we're asked to blast. So we have data redundancy increasing as there will be many columns with the same data in multiple rows, but each row as a whole will be unique. So this is unique because we're dealing with biology. This is unique because we're dealing with Adams doing math. This is unique because Alex is doing math and Stuart is doing math. Any questions so far? So remember, you pull from the source. And when you pull from the source might say, you know, for example, if you're taking in a student into sixth form, and they say to you that they want to do a particular set of subjects. So they say they want to do K, math, what else? Maybe IT, econ, but they would give you all of that in one row, you know, unless you give them something to tick off. But when it's all said and done, those are the subjects that they want to do. And in your table, you might record all of those subjects that they want to do in one cell. We don't want that, so we're going to blast it. All right? Let us move on to the next step. Second normal form. Now, there must not be any partial dependency of any column on the primary key. We can't have partial dependency. Everything in the table must be dependent on the primary key. Everything must be dependent on the primary key. No partial dependency. All right? So it means that for a table that has concatenated primary key, that means more than one fields coming together to form your primary key, each column in that table that is not a part of the primary key must depend upon the entire concatenated key. So what is that mean is if you have two fields that make up your primary key, when you look at another field that is not a primary, it's not a part of that primary field, you must ensure that that field is not dependent on just one of the fields that make up the primary key. Am I making sense? If I'm not, tell me no. So we have field 1 and field 2 that makes up the primary key. And then we have field 3. That's not a primary key. That's not even part of it. But if we find that field 3 is dependent only on field 1, then that's a problem. Say it again. Every time I send you for lunch, when I come back, want to sleep. What is wrong with you? Wake up, stretch. No. Everybody looks sleepy. Next time, tell me what you understand.
All right, you said that with the first normal form, redundancy increases.
Yes.
All right, moving to the second normal form now, you say that in instance where we have a primary key, you said a concatenated primary key.
Yeah.
All the elements in the record should depend on the primary key. Should depend on all the primary keys. So if you have two primary keys.
No, you have more than one fields making up the primary key.
Right. That the other fields should be dependent on two primary keys. If it's two primary keys, if it's two fields that make up the primary keys,
yes.
They should be depended on. For one of them.
Yes, it is not supposed to be dependent on just one of them.
Right.
And if it's made up of 3, it shouldn't be dependent on only 2 of them. Because if you have that kind of situation, then we realize that you are violating the whole second normal form rule. All right? Let us look at an example here. So, for example, right? So in the example of the first normal form, there are 2 rows for Adam to include multiple subjects that he has opted for. So while this is searchable and follows first normal form, it is an inefficient use of space because we have too many repetition as it relates to Adam. So also the table in first normal form, while the candidate key is, all right, so what if the candidate key was student and subject, right? The age is dependent on the student. Agree or disagree? The age is not dependent on the subject.
No.
So if we chose to have a concatenated key, and the key is made up of both the name of the student, or is it ID? What we have? ID? Student and the subject. What if we use that to be our primary key? You'd realize that age is simply just dependent on student. It's not attached to subject any at all. So that would be violating the second normal form. I'm going to let that kind of seep in a little. So remember now that we have to look at second normal form, not from the unnormalized table. We have to look at it from your first normal form table. So the first normal form is the one that had Adam is the age of Adam and the subject, physics, I think. Then you have Adam again is age, and then you have math, and then you have the other two students with their math. So when we look at the first normal form table, that's a table we're going to use now to make sure that it addresses the second normal form issue. So what if we chose the name of the student as well as the subject that the student is doing? We use those two to make our primary key. Well, the only one that is left out is the age, and age is completely dependent on the student. You never look at somebody's subject and say, you know, the subject age is so and so. Yeah, the age is completely dependent on the student. So to achieve the second normal form, it would be helpful to split out the subjects into an independent table. So now, guess what we're doing? We're no longer having one table now. We're going to have maybe two, maybe three. It's dependent. In this case, we're going to have two and match these up using the student name as foreign key. So we are now deciding to not keep all those three fields together in one table. We are now deciding to blast it. And we're going to keep the student name as the primary key. So let us look at this example now. So, new student table following the second normal form. So now we have a student table with just everything relating to student. So the age, student. Then we have a subject table now. And in the subject table, we see that we are attaching what? To each student, the subject that the student is doing. Of course, you notice that the subject table has an issue. Anybody realize that? Look at the subject table. You still have redundancy issues with the subject table, agree? Well, it would not be an issue if you make it the primary key, if you make both of them the primary key. So let us see. If we decided to make the subject table have a candidate key, then what is going to happen? Then what is going to happen is that you're going to have the student and the subject fields making up your primary key. And in that case, you don't have any redundancies. I feel like I'm talking to myself. No? Or I see Dexter saying yes. I see Courtney swaying. I see Dana smiling. Do you know what that means? You know? Jessica, you with me? That's so funny. All right, Ophelia. Rosalind is a fool? Yeah? All right, cool.
It's the newness.
It's a newness. Aye. All right, so let's see now. All right, so when we're going into the second normal form, it's obvious that we're going to need to blast. Why are we blasting? Because we realize that the primary key that we have, two fields making up the primary key in this case, we find that we have fields that are dependent on just part of the primary key. If that happens, you just need two tables. All right? So in the subject table, the candidate key or the primary key is going to be student and subject. And then that's when you would have unique values because you have Adam biology, Adam math, but those are two different primary keys. All right? Now, both The above tables qualifies for the second normal form and will never suffer from update anomalies. Although there are a few complex cases in which a table in the second normal form suffers from update anomalies, and we're going to be looking at the third normal form. So time for third normal form now. So every non-prime attribute of table must be dependent on the primary key. So every non-prime attribute of a table, that's non-primary attribute of a table, must be dependent on the primary key. Or we can say that there should not be the case that a non-prime attribute is determined by another non-prime attribute. So now we're looking at the non-primes. So we're not looking at the primary keys now. We're looking at the non-primary keys, the non-primary fields. And we're looking and seeing if we have a non-primary field that is dependent on another non-primary field. Because if that happens, we have to separate. So this is a transitive functional dependency and should be removed from the table. And also the table must be in second normal form for you to be able to do that. So the advantage of removing transitive dependency is the amount of data duplication is reduced and the data integrity is achieved. Oh Lord. So, yeah, I know when students are absorbing, you're not absorbing a thing. All right, the last one. All right, let me see if I can explain again. Okay. So for the first normal form, right, you're looking for columns or for fields that can hold more than one data. So you have separation by commas. You don't want that. So what you're going to do is remove those commas and you're going to have a table now with maybe more than one. You're going to have data redundancy taking place. Yeah? So you're going to have repetition. All right, but the whole idea is that you would have gotten rid of those commas. For example, with the subjects update. All right, now we have the table in first normal form. We need to get it into second normal form and behave in itself. Now, how do we deal with that? Well, it's in first normal form. So what we're going to do now is look at all the non-key fields. So we're looking at all the non-key fields and we're trying to determine if any of them dependent on piece of the primary key. If any of them is dependent on piece of the primary key, that means that we need to blast that table. The third normal form now takes a table that's in second normal form and it's going to say, okay, what's my next step? The next step is to make sure that the non-key fields, none of them is actually dependent on another non-key field. Oh Lord. Tell me what you understand.
Sorry.
Yeah.
That sounds like what you said for the.
Yes. It sounds like the second normal form, don't it?
Yeah.
Yeah, but I want you to pay very keen attention to the difference. The difference is that with the second normal form, you are focusing on the non-key field being partially dependent on just one of the key fields. So non-key field dependent on part of the key field. The third normal form doesn't look at key field any at all. What it is doing is looking at the non-key fields and looking and seeing if you have a non-key field that is dependent on another non-key field.
Gotcha.
You got the difference?
Yes.
Yes.
So you said second normal form, you're looking at the prime key field and see how the non-prime relates to the prime.
Yes.
And for the third normal form, you're not looking at the prime keys at all. You're looking how the non-key fields relate to the other non-key fields.
Yes. And if you find that one is completely dependent on, like one non-key field is dependent on another non-key field, then it means that we are violating third normal form. That's where the problem is. We don't want non-key fields becoming dependent on another non-key field. We don't want that. So we have to ensure that we blast that again. All right? So what will help us in understanding, though, is an example. So let us look at this example here. So we have student ID, student name, date of birth, street, city, state, and zip code. All right? Now in this table, the primary key is student ID. But if you look at it, you'll realize that but street, city, and state, it actually depends on the zip code. Agree or disagree? You notice that the date of birth is very dependent on the student. So that's fine. But street is not really dependent on the student. It is dependent on the zip code. So it's a city, so it's a state. So what we do now is that we have to go blast that table. And then what we will keep is the zip code that the student lives in. But the zip now, we have another table called the address table. And the address table is going to now have everything relating to it, which will be the street, the city, the state. What would be good is if you could come up with an example and show me how something would be a transitive dependency. I'm going to give you 2 minutes to think of something. It can be in school, anything at all. A banking situation, anything at all. You good? Of what? Yeah. You want to know? Just think of an idea, think of something that could have a transitive kind of situation. Come up with any example here? All right, Jessica, you want to share something? You come up with an example? Just tell me the fields and tell me what you realize would have been a transitive situation or dependency.
I'm not done as yet.
All right, but can you tell me of the scenario that you're thinking of?
I have not come up with anything as yet, to be honest.
All right. Who said?
Let me try.
Yes, Ophelia.
Okay, I have patient's ID, patient's name, date of birth, address, and patient's number. Patient's ID as the primary key. And I have date of birth. Many patients can have the same date of birth. So that can be a problem.
Okay, so, all right, so your primary key is what again?
Patient's ID.
So tell me of the transitive dependency that you saw from your example.
That the patient's name, the patient's ID depends on the patient's name.
All right, so the patient name depends on the patient ID. You want to talk it in relation to the primary key. So your primary key is the patient ID. So having the patient name being connected to the ID is fine. Tell me the other field that you have.
I have date of birth, but I'm seeing date of birth can be a problem.
Okay, and why is it a problem? Because more than one person can have the same date of birth?
Right.
Well, that's not a transitive dependency. because that date of birth is tightly coupled with the patient. That's when that patient was born.
Okay. And then I have the address and the patient's number.
Okay, which is the same thing as the ID, right?
Right.
Mm-hmm. All right. How about I add something to that?
Address can create a problem. Because you can have many patients living the same area or the same place.
Yeah, but still that address is where that patient lives. So that means that, you know, it is dependent on that patient. But I can give you an example. I'm going to add some other fields to your table, right?
Okay.
What if we put in that table also the ward that patient is on, and the number of beds on the ward, and the number of nurses on the ward? You realize that the number of beds is tightly related to the ward number.
Yeah.
The number of nurses is related to the ward number. So what we have is some non-key fields, right? The number of beds, the number of nurses being totally dependent on the ward.
Yes.
So that shouldn't have been in it in the first place. So let me just open up a Word document and show you what I'm talking about.
So that's two independent keys? So it has two independent keys?
If that is what?
If it has two independent keys.
Yes, what you're going to do is blast that into two tables, and then each table will have its own key.
Right.
You see where I'm coming from? So everything that you had said before, the initial example that you gave me, are things that are tightly associated with the patient, right? So those wouldn't pose a problem, right? So, okay, I am going to stop sharing my screen and start again to show you the Word document. All right, so what we have first, you said that we have the patient ID. And you said that that is your primary key, right?
Right.
And then you're saying with patient ID, you have the name of the patient, the date of birth, what else?
Address,
and then
patient
some
number.
stuff. Oh, patient number. But patient number and patient ID not the same thing? Did you answer that?
No, as in the telephone number.
Oh, telephone number. Okay, call it that. So telephone
number.
All right. And then I was saying to you, what if you put ward and number of beds?
And number of nurses.
And number of
nurses.
All right. So immediately you see that this is violating the third normal form. Why is that? Because we realize that. Yes. Exactly. We have things here that don't depend on patient ID. You know. So yes, we want to know which ward the patient is on. That's good. But do we need to know the number of beds?
No.
Do we need to know the number of nurses? No, because those are tightly dependent on the ward. So what we recommend is that for third normal form, we got to take this out. And not everything, because you still need to know the ward that the patient is on. That makes sense, right? So what we have now is two tables. One table with everything relating to patient, while the other is everything relating to the ward. And then the ward, obviously the ward number, let us put ward number, is going to be our primary key.
Okay.
Am I making sense? And then which two would be?
Yes, but
yes. What are you saying, Ophelia?
I was saying after telephone number you have ward, so it wouldn't be ward number?
Yes,
just ward?
It's the same ward number.
Okay.
Because I was about to say to you now that we would now connect the two tables by using the primary key of our ward table, which is ward number, and connect it with the foreign key in our patient table. Yeah? So this would be our patient table. Yeah? Oops. Go back. That would be our patient table. And this would be our ward table. Yeah? And then now we realize that the primary key of my word table is now going to be connected to the foreign key of my patient table, and that's word. And if you feel more comfortable putting word number, sure. Same thing. All right?
Yeah.
What type of relationship you think would exist here?
That's what I want a patient word to word.
It will be a what?
A one to one. Well,
unless you have only one patient per ward, is a rich hospital. Yeah?
One patient to many patients to one ward. So it's many to one?
One to many. Yeah.
One to many?
Yeah, we don't call it many to one. It's one to many.
Okay, one to many.
Yeah. All right, so look at what is happening here now. What you realize is that you'll only see a ward represented once in here, but you'll see it represented many times in here. So each ward can have many patients, while each patient is only on one ward, a one-to-many relationship. All right, who wants to give me another example? Thank you, Ophelia.
Okay.
Rosalind, you have one?
I'm not sure, miss. I have something, but...
All right, share it with me and let me validate it for you.
Well, actually, I was just trying to come up with a process of being a student at a school and being able to represent the school. So, for example, I have something like, okay, the student name.
So you're
I have I have registration. Tell me if it makes sense. I have steps. I have registration, then orientation, then registration, acceptance, orientation, class attendance, and school representation, so to speak. And then I was trying to put in something like the student name, etc., etc.
Okay, so all of what you mentioned initially were tables?
Well, not really. I was just looking at trying to understand what's happening, what we're doing, and trying to come up with steps, like steps that a child or student has to go through in order to be able to represent their school. So first they have to be registered. And
so what kind of data would you collect to say you're checking if they're registered? Because, all right, what we need to understand is that you must identify the tables, the entities. And I haven't heard what tables you want to work with.
Okay.
So, okay, if you're going to register a student, tell me the data that you would need to register a student.
Well, I would need their name, their where they live, their address. Well, again, their date of birth. I don't want to use the same thing that we're using. All right, date of birth, the parents' name.
Yes.
Parent name.
I like where you're going with this now. What else?
Well, some schools, maybe some schools have the medical record or something.
All right, so you have, but tell me what kind of data I would put there, like the medical doctor.
Yes, the doctor's name, doctor's number, like that means telephone number.
One second. So you have doctor name, doctor
number,
yeah. What else?
And doctor's address.
Doctor address, okay. And all of this you are collecting on the student, from the student?
Yes.
Okay, so if you're registering the student, we can't stop here. Of course, I've seen opportunities to explain, right? So,
okay.
So we're looking at you registering a student. And to register a student, you're saying that you would need their name, address, date of birth, parents' name, doctor number, doctor address. What's your primary key here?
The student's name?
I would prefer if you brought in an ID. Remember we spoke about that last time?
ID. All right, yes.
You have two students
so then
in
it's
a school
missing
with
an
the
ID.
exact same name. All right, so can we just say ID for that?
Yeah. Okay.
And that is going to be your primary key. Agree? All
yes.
right. Now, can somebody look at this and tell me if it is obeying the third normal form?
If it's in the third normal form?
Yeah. Is it obeying? Because the third normal form says that you should not have non-key fields, and I'm going to highlight my non-key fields now. So, Rosaline, these are your non-key fields. Yeah? So, we have some non-key fields here. Is there any non-key field in this list that is dependent on another non-key field?
Yes, Miss.
What's that?
The doctor's name.
Yes.
Doctor's name, doctor's number. The doctor's address. You can put it separate, like we did previously for mine.
Exactly. So what you are seeing now is, and that was Ophelia, right?
Yes.
Right.
Right. So what you realize here is that you may want to know the doctor's name. That's all well and good. But really and truly, these two shouldn't be in that row any at all, or in that table any at all. Why? It has nothing to do with the student. It has to do with the doctor. So we just need a doctor table now. Yeah? And then for the doctor table, maybe we should give the doctor an ID number. Huh? No, it's a telephone number, I think. Yeah. And then we have doc name. But tell me now, how is it that we would, so maybe changes from doc name to doc ID. And then the connection now would be from here to here. And what type of relationship would exist here?
Well, one to many?
One to many, because each
one doctor to many
can process more than one student, many students, while each student should be processed by one doctor. Should be. But then, you know, if we're talking about the medical, when you get a medical from the student who is just entering the school, it's normally from one doctor. I've never seen a student come in with two medicals. The same.
That's true. It would depend on their own situations. I mean,
it's true.
It's specifically for registration.
I have many doctors.
Specifically for registration, I was just taking Rosaline's thing. She was saying this was for registration.
I'm thinking, if a child has
some critical illness,
there would have to be a doctor that specifies to that. Now you go to get a medical done, that's one doctor, but then your regular doctor would know your history of whatever. There may be a section that they have to sign or something.
So what we would have is a many-to-many relationship. And if we have a many-to-many relationship, what that means is that we're going to need an extra table. Yeah? And that one would be your student doctor. This will be your student doctor table. Right? And the student doctor table will have the student ID, which is a primary key of the student table. And you would also have the doctor ID. Yeah. And then those two will make up your primary key for this table. So what we have now is two one-to-many relationship. So we'll have one representation of student in the student table, but they can have many doctors, one or more doctors. while you have a connection here between Dr. ID, and Dr. ID in that table, in the doctor's table. So we have two one-to-many relationships. So we don't have a many-to-many situation. So you notice that it is important that you understand the environment for which you're creating the database for. Because I jump and thought only one doctor can get the thing from. Yeah. But from your experience, you're saying you could get two medicals, one from a specialist or two from specialists, and another one from just a normal medical doctor. Yeah. Anybody want to give me another example just to see if we understand the whole idea of the third normal form?
Okay, I have one, but I'm not too sure if it is. Going through that, I probably realize that mine might not be the best one.
Do you want a minute or two to figure it out and then tell me?
Well, we could figure it out together with the help of my colleague.
All right, let me hear.
Okay, I have like for a provider, a service provider, like cable.
Yes.
I have customer name, customer ID.
Who are you representing? The customer? Okay. Start saying.
Customer name. Customer ID.
Yeah.
Address. And I have service package or service type.
Okay, service type. Yeah.
Okay, and from that you could get internet. You could get.
Oh, so you're saying the type is either internet, cable, phone. Okay.
Yeah.
So, okay, what I'm seeing now is if we're going to represent the whole idea of third normal form, right? We maybe have to put in the service cost into it. Yeah. Anything else about the service? We have the time, we have the cost. Anything else?
That's why.
Service type because we have to be specific.
Right, but she has that already. She has a service type. So what would happen is that you have a violation of like internet, cable, phone, complaints. Okay. And the complaint would be about a particular. I think she's talking about register. You're talking about registering a new customer?
Well, not registering, but then existing customers.
All right. So every customer you
technician dates.
So you would have things like the help desk. You would have the complaint desk and this kind of things. I don't know if it could.
So you're saying you're storing data also on the complaint, the technician.
Yeah, the technical.
Yeah, and maybe the date of I don't know. The date the technician came in. Visit date.
Visit dates.
You also need a report ID as well.
Oh, a report ID?
Yeah, because if you're saying a complaint is going to have a particular report that's associated with it.
Okay, all right. Okay, so all right, so you're talking about an existing customer and say something is going wrong with the service that you offer. The technician goes to the house and they check out the whatever and they have the person sign to say, yes, the technician came. But the source document would be that document that, that prove that the technician came to the place. It would have their address on it, their name, the service that they have, what's the cost of the service, I guess, and stuff like that. Agree?
Yes.
So how would we ensure that this table obeys? You know what I should do now? This is a great opportunity to ask, is this table in its second normal form? because it should be in its second normal form before you could even think of third normal form. So we have to identify the primary key first. All right then, but if you have only one primary key, then it is safely in its second normal form. Anybody disagrees?
I don't think it's in first normal form.
Yeah, we should have really checked first normal form. But you notice I'm doing a bottom-up approach. Yeah. So come again. Before we even think of doing third normal form, let us look at if the table satisfies the second normal form. Now, if you have only one primary key, then it cannot violate second normal form. Because second normal form is, I'm going to move the primary key to be in the first, because that's where we always put it, right? So if it violates second normal form, for it to violate second normal form, you have to have more than 2 fields making up your primary key. But only one field here is making up your primary key. Is there any other thing we could use to make up our primary key here? You know you can talk to me, right? Would you want to make anything else lock with the ID to make up the primary key, or ID is good enough?
If we're storing information about the customer?
Yeah, we're storing about the complaint that took place.
Well, if it's about the complaint, then the complaint number.
Then the complaint number. All right, complaint number. So, okay. So we're going to call this table customer complaint. How about that? Guys, you have to help me now. I'm feeling lonely right now, except for Thalia. I'm begging for some attention, please. So Thalia is saying that she would have loved to put complaint as part of the primary key. So I'm going to bold that also and underline it. No, this is possibly not in its second normal form. Because if you have anything here that is dependent on just part of this primary key, our primary key is made up of both ID and complaint number. Yeah? So if we have any non-key field, that's the ones that are not highlighted and underlined. If we have any of these fields, depending only on part of it, then we're going to have an issue. Are there any non-key field dependent on just part of the primary key? That's a question. Any non-key fields here dependent on the primary key? Part of the primary key?
What about name dependent on ID?
Yes, and what else?
The address as well?
So what you're saying is that we really should have a customer table. And in the customer table, you can have your ID number.
ID.
Yeah. And you will have the name
and
the address. All right. Is there anything else that is dependent on the ID?
What about the service type?
The service type?
No?
I'm thinking. So you're saying for the customer, you'd need to know the ID number, the name, address, and the service type.
Yeah.
All right. That's Bible, Dana. Thank you. What's next? Is there anything, but if you have the service type, Dana, maybe you want to know what's the cost too. Yeah? What's next? Is there anything that was dependent on the complaint?
The technician.
So we have a table called complaint.
Complaint. Mm-hmm.
And then we have a complaint number. Something like that, right? What else? The technician, you said?
Technician, yes.
And the date. Yeah? And
visit date and report.
And the report, okay. Did we leave out anything? What does that mean now? It means that our customer complaint table, is going to have only the ID number and the complaint number. All right, so the primary key for the customer table would be the customer ID. Both of these would make up the primary key. And then what about this? The complaint number would make up the primary key here. Anything else could make up the primary key?
The date? No.
I would think that complaint number should be fine, seeing that it should be unique. What do you think? All right, but if you want to use a date, say you want to use a date, we can maybe buy into that. Let's see. All right, so we have two things making up the primary key here. All right, cool. Uh-oh. Habit of saving. All right, where are we now? No, okay, so you're saying when we look at this now, is name totally dependent on ID?
Yes.
Mm-hmm.
Is address dependent on the customer? The service type, is it dependent on the customer?
No.
But we need to know what service the customer is getting.
Okay.
So that is important. But the service cost, is it dependent on the customer?
No, it depends on the service type.
Exactly. So this is where we know that the customer table is violating. The customer table is violating the third normal form. So we know that when we go to third normal form now, we're going to realize that we have to take this customer table, yeah, and now we'd have to we'll keep the service type because we want to know what service the customer is getting, but the service cost will have to go because it is totally dependent on the type.
Oh.
And now the type itself would be the primary key. Agree? Talking about third normal form here. Yeah? This one was for what now? Second normal form?
Well, that one actually got split because of first normal form.
Hmm?
I said that one actually got split because of first normal form.
Which one?
Oh,
The first one here? Yeah, this was the one in first normal form. Wait, deselect it. So in first normal form, what we did, so hold on, I want you to help me here. Was this in the unnormalized state or not?
What you had there for first normal?
Yeah, for first normal form. Is that in the unnormalized state where we just pick up everything from the document and put it in one big table?
I would say so.
And then for first normal form, is there going to be any service type here where you're going to have repetition?
Yeah.
Because so what if a person takes out cable and internet? Then this one here is going to have for maybe for Karine, you're going to have cable, comma, internet. Then maybe for Dana, you have cable, comma, telephone, comma, internet.
And if heaven forbid they had more than one thing wrong.
So what is going to happen is that
and the technician and
yes.
Line chip out, line chip
Yeah.
out, line chip out, line chip out for different dates.
And what if the person changed their address? That's going to be a lot of problems. So in first normal form, we're going to see an increase in redundancy. I just put that here. We're going to see, Control I, an increase in redundancy. Am I spelling something wrong here? Redundancy. Yeah? Okay. Because of multiple representation of what? Of customer. If customer has more than one service types. Anything you want to say to me? I know it's new, so it's going to take a little time to process. You're going to say something, Dexter? Okay, so we got the table in first normal form, and when we got it in first normal form, we said, fine, we're going to have a lot of redundancies. That's okay. So what we did, we said, all right, now that we know that we have a number of redundancies, how are we going to get rid of it? Let's go to second normal form. When you go to second normal form, you realize that there were some things here, some non-key fields that were dependent on piece of the primary key. So what we did, we made a customer table, and everything relating to customer would be in the customer table, and everything relating to complaint would be in the complaint table. So customer complaint table now would just have the ID numbers of customer table and complaint table. Fine. That wasn't good enough, because while customer complaint table is all right, while the complaint table is all right, we realize that the customer table isn't okay. So what's wrong with the customer table? We realize that we have service costs, which is a non-key field, being dependent on service type, which is a non-key field. So what we did is that we blasted that table, and now customer table has only ID number, name, address, and service type, while service table has service type and service cost. Good? So let us see now. What is it that, what are the tables that we will be using from henceforth now? For the way forward. I'm looking for a tick. All right, I have a better way to get it. Give me a second.
That sounds like you're searching.
Yeah, man. Yeah. You see it? Oh, no. Yes. Yeah, man. I'm looking for a check mark. Yes, see it here. Problem solved. All right, so what is it that we're going to be using now? We're going to be using this table. we're going to be using this table, complaint, and that one. How are we doing so far? I know, not one of the easiest topics to teach, I'm trying. Give you some time to process it. And then I want you to look at the first activity for normalization on OUR-VLE. Look at that for me and see if you could check it out in first normal form, then second, and then third.
Miss?
Yeah?
Why are we finishing at 5 today?
We're not finishing at 5.
5 their time.
Oh, 5 their time.
In my time.
Oh, why we shouldn't finish at 5?
Okay, why are you finishing at 4 in your time?
I got what you were saying, Ophelia. I thought we were supposed to be finishing at 4. It's 3?
No, right, she just wondered why.
Remember that we missed a class last week, agree?
Mm-hmm.
That class is worth how many hours again? 5?
I thought you had done all the hours already.
We have done 5 already? No?
No, I thought we had done all the hours already.
To make up for the one class?
So on Thursday, we're going to have class until 4?
Alright, let us work it out. Let's go again. We normally would have class from 9 to when?
9 to 3 in your time.
Okay, so we would normally have class from 9 to 3, so that's 5 hours, agree? Minus our lunch time, right? So on Thursday, we did how many hours extra? 2. Right?
Mm-hmm.
And today we're going to do 1 hour. That's 3.
Yeah.
Right? Thursday we're going to do an extra hour. That's 4.
Mm-hmm.
And then next week, Tuesday, we do an additional hour, and that would make up for the 5 hours.
Lord have mercy.
Don't tell her what next week then.
You tired of failure? Is that the problem?
That's okay.
Yeah. When it look like how it did look last week when we have to finish the class. All right. Okay, so let's see. It's soon 3:45 anyways. I need to give you some time to absorb this, obviously. Yeah? So what's the consensus? You want to ask me some questions and then we finish? And then you try the normalization questions on OUR-VLE?
Sounds good, miss. Sounds good.
All right, and then when we come in on Thursday, when we have class on Thursday, what we will do is we'll take the first hour going through normalization. Okay. The activities that you got for homework, so to speak.
Okay. Well, miss, question for you.
Yeah.
All right. I have not looked at the activity on the VLE.
Yeah.
As yet.
Yeah.
But a question pertaining to this on the exam.
Yeah.
What could it take the form of? We get in a table and we ask to normalize it. First, second, third, fourth.
Yes. Not fourth, third. So what you will get is an initial table. Yeah. And in that table, you will find columns with more than one data inside of it.
Okay.
Right? So for example, we may say to you, okay, we have customer complaints table. We pull that from a form, right? And we have a table with 1, 2, 3, 4, 5, 6, 7, 8. Good. Give you a table like that. You put ID number in there, complaints, complaint number, sorry, name, address, service type, oh boy, this is not my keyboard, so what else? Service cost. So we give you something like that, right? The technician ID, the visit date, and so forth. Then we would maybe give you the customer ID. The complaint is
broken cable.
Broken cable. Address. Oh, sorry. Mary Jane. Address is
21
Apple Valley. Yeah. And then the service type is that you may have cable, internet. Yeah. Service cost is maybe 2,000, 5,000, something like that. The technician is John Doe, right? And you have the date, March 5th, 2015, I don't know, making up some story. And then you have another.
That's my birthday.
Really? You go, girl. All right. You know what I'm saying? All right. What other problem we can have? Maybe with the internet. No service.
Not logging in.
Okay, not being able to log in or something, you know, and then this one is
working.
This is John.
Router giving error.
All right, John. No. And yeah, and the address is Pineapple Drive. I don't know. And he only has internet. Yeah. And then the service cost is maybe 5,500. Who came and saw him? K King. And
but they came 2 different times.
April
7th and April 8th. Nobody was home on 6th.
Oh, 2 different times.
Yeah.
Oh, cool. That can work. So April.
2017. Wow.
Oops.
You're on fire. Miss, are you tired?
I am. Right? I won't lie, I am.
That's big fatigue?
No.
It's just much.
Never ate that much to have that.
It's just much.
And it's 2015? Mm-hmm. All right. So, next one, you see what we're talking about? So you get a table like this, and you have to make it into, so let me just cut that table. It should not be there. It should be up here as an unnormalized table. Yeah? So we give you this, what? Undo. So we have this as the unnormalized table. You'll get more records though, believe it or not. So you have your unnormalized table. And then now, right, that unnormalized table for you is a problem. So is it okay? Is it obeying the first normal form?
Well, I would guess to put it in first normal form, we would, as you say, blast the service card. No.
No, it's not time to blast yet.
No?
Not time yet.
For first
okay.
normal form?
For first, not that kind of blast. In terms of, you'd have to make a copy of this. Yeah?
Okay.
And then you're going to take away the repetition now. So you're going to then just the cable.
Right.
That making sense?
That's what I was going to say.
Oh, that's what you meant by the blast.
Yes.
Oh, because when I thought of the blast, I was thinking more of blasting into 2 tables.
Oh, no. Just repeating the entries for the same individual.
Oh, okay. All right.
Removing the command.
Here.
And for John Mark's dates.
Yeah, so we have to go copy John Mark's too. But the dates are going to be different, yeah?
Right. One for the 10th.
So one is for the 8th and one is for the 10th. Are we cool so far?
Yeah.
So obviously, you see the redundancy increasing here.
Right.
All right. You're going to take this table now, and you're going to say, look here, we have a problem with this table. Because we really should not have this repetition thing taking place. Yeah? But not only that, the second normal form is extremely specific. Because the second normal form says that we should not have any non-key fields relying on just part of the primary key. And remember that we had agreed that the primary keys are actually ID number and the complaint number. That's what we had said, right?
Okay.
And we saw, and we blasted that because we realized that we had non-key fields dependent on just piece of the thing. Yeah? So what did we get from that? We got 3 tables as a matter of fact. So the first table is just going to have ID number, name, address, service type, and service cost. So it means that we're getting rid of this row, this column, We're getting rid of the tech column. And we're getting rid of the date column. How are we doing so far? Winding now, yeah. Yeah. But at least you will have this to look back on, right? When your brain sorts out. Okay, so the next table is the customer complaint table. And the customer complaint table said that we need to get rid of all of these. Good? Then we have the third table, which is the complaint table. It has a complaint number, date, report, and the technician. Complaint number. What did we have again? Complaint number, date, report, technician. I didn't put reports in the last set. So we'll just take a report in. All right. Oh, we never got rid of this. All right, so realize there's an issue here for third normal form, but that was just for the customer table. So we took the customer table. Yeah. So we took the customer table. And we're going to blast that in 2. So we have ID number, name, address, and the service type. Then we're going to copy these, paste them there, and then get rid of this column. All right, guys. I feel like I'm fighting a losing battle. Yeah, look. No? All right, so what I'm going to do is I'm going to save this. I want to save it right now as what? Class activity. On normalization?
Yes.
Go to the desktop there.
Don't.
You see it? Okay.
Okay.
All right, so class exercise on normalization. And take the time out to just go through it again and then try the and then try for me the two questions that you have to do on normalization. All right?
Yeah. We'll use questions and upload it to the VLE, right?
What's that?
The two questions, when we have tried them.
Yeah, put up a submission link. Yes, I put up a submission link for it.
Would it be graded instantly? Or are you just for diagnosis purposes?
No, it's for when we it's for when we meet again.
Okay.
We're gonna take 1 hour and just go through it.
Okay.
Yeah. So give me a sec. My brain focusing on this right now.
So exercises are the ERD that you was talking about?
Sorry about that earlier, miss. I had to run out to take a very important call. So that's why you...
Is it gone?
I didn't notice.
Everybody's so quiet today, Courtney. Or after lunch.
That is not nice. I don't believe you didn't miss me.
No, everybody has been quiet.
I was hearing you guys though.
Oh, great.
That's great. Oh, the two that next one is talking about two normalized activities or the ERB you're talking about, the upload.
Come again.
He said 2 exercises to upload.
No, he wanted to know if he should upload the normalization questions. And it will be good for you to upload it. Yeah? So when we come to class, I'll be able to pull on the ones that maybe nearest or we could work from to get a better understanding. We were supposed to discuss it? Remember we did do them. Yeah, because
that's what he said.
Yeah, so those were just for practice.
Just checking.
Yeah. All right, so it's up on OUR VLE, so you can refer to it again. All right. Yeah, guys.
You said, Miss, we. Excuse me, please. You said we should post it after.
Yes.
Oh, wait.
The submission link. When you have tried it and everything, you can upload it for class on Thursday.
Okay.
All right. I'm sure you'll be fine. Remember that the first time you're learning something, it might seem far-fetched, but with practice and everything, you'll be fine. All right.
Okay, Miss, you said you uploaded this example, right?
Yes, yes.
All right.
So it's on OUR VLE, so you should be fine.
Okay.
All right. So we're going to end the class now.
Sorry, just a quick question before you go, Miss.
Yes.
I'm not sure which part of the conversation I had missed. So I'm hearing that we should do something and upload it. It's the normalization activity that you're talking about?
Yes.
Okay, and we should upload it by Thursday or for
by
class?
Thursday morning, before class.
Before class?
Yes.
Okay.
And I uploaded the activity that we did a little while ago. So you can take a look at it when your brains are all rested and ready to kick again. Yeah? All right. So I pray that the Lord will give you understanding when you are revising. I pray that He will give you clarity and that you'll be able to apply your knowledge and that you will do exceptionally well, that He will give you peace and that He will give you a sense of calm, that you will be able to do exceptionally well in this course. To give you thanks in Jesus' name. Amen. Bye, guys.
Amen. Bye.
Bye.
Bye. Bye-bye.
Oh, and recording. Oh, jeez.
Okay. Bye-bye.
Bye, guys.